Okay, first off, I want to point out that I did not assign an IXL lesson over this material for two primary reasons. One, for those who are working the problems, it is so easy to make one small mistake and leave a negative off and end up with an incorrect answer, and it can become very frustrating. And I don't have a chance to see your work to help you figure out where things went wrong. And second, because some people, when I assign IXL, are not actually doing the problems. They're just using a math app, taking a photo, and then putting in the answer. So it's very obvious when there are long questions and students get the answer in a mere second or two, when it would take that long just to write the problem down. And then those same students have difficulty working the problem on paper because they haven't actually worked the problems. So I do need to see your work for these problems. Your work doesn't have to look exactly like mine, but it should not just be answers without any steps. All right, so now I'm going to assume that you are still here because you want to know how to do this, that you are not just looking to take a photo of it with an app on your phone and magically get an answer, because that doesn't really help you learn. It could help you check, but it doesn't really help you learn. So, now that we got that out of the way, so here at the top of this page, if you looked at the top of this page, you would see there's like a whole page and a half of steps. Basically, we are still simplifying each side, but now, which includes distributing and combining like terms if we need to, but now we need to move a variable because we have to get the variables on the same side, and then it will be a two-step equation. So, in this case, the first thing we're going to do, again, is distribute. So you'll notice that many of these steps are the same. In this case, after we distribute, 5 times 5n, 5 times -1. After we distribute, we don't have any like terms that are already on the same side. So we won't have a combined like term step. What we're going to have is we're going to move a variable. In this case, I personally would move the 8n, the -8n. So I'm going to do that by adding 8n. So I don't want my n's to be on this side, so I'll add 8n to get rid of them. It's okay if I do that as long as I also do it over here. Again, you can also think of that as moving it from the right to the left side of the equation, and then when it crosses the line, it would have to change its sign. So then I have 33n minus 5 is equal to -38. And now that should look like something in the comfort zone. Now we're just ready to add 5, so we're going to undo the subtraction by adding. Same thing over here. Pay attention to those signs. And then divide both sides by 33. So divide by 33. And n is equal to -1. So in this case, we did not have a combined like term step for things that were already on the same side, but we oftentimes will. So let's take a look at another one. I'll want to find one that has, some of these have combined like terms, but they do not have, let's look at number 4. I guess 3 and 4 are very similar. So we'll say, we'll say 4. So on the left side, there's no parentheses and there are no like terms. So it's as simple as possible. On the right side, we have some like terms. 4x, take away x, remember that's like saying take away 1x, becomes 3x. The rest of the problem at this point is staying the same. Now I want to get my x's on the same side. It could be the left side or the right side. Most of my students feel a little more comfortable when they're on the left. Perhaps I shouldn't encourage that because it's really the same either way. So negative 4 minus 1x, or just minus x, is equal to 1. So I've moved a variable so that my variable's on the same side. Now I have a two-step equation. I can add 4. And then divide by negative 1. So x is equal to negative 5. Okay, so sometimes that first step about simplifying could be combine like terms, sometimes it could be distribute, sometimes we'll have to do both. So next up, I'm going to find a problem where we have to distribute and combine like terms before we move the variable. Well, as it turns out, there aren't any that need distribution, or distribute. Yeah, we don't need to distribute and combine like terms on any of these. But here's some where we have to distribute. I'll go ahead and work number 7. Again, you'll be finishing the ones of these that I haven't done with you. So it'll be kind of obvious if someone didn't watch the video, if they get the ones wrong that I did, right? So I'm trying to help people out, but I can't force people to watch. 4 times 1, 4 times negative x. And then I need to get those variables on the same side. And just to show you that it works both ways, this time I'm going to do something a little different. I'm going to move my variables to the right side. So I'm going to add 5x and move the variable off the left. Nothing magical about the left side. Negative 4 and positive 5 would just be 1x, so I could just write plus x. And then when I do that, now it's not the negative 2 I want to move, it's the 4 I want to move because I want things away from the x. Remember, you're supposed to isolate, get the x by itself. So subtract 4 on both sides. Negative 2, negative 4 makes negative 6 is equal to x. In this case, that also had one fewer step by putting it on that side. If I had put it on the left, it would have been negative 1x if I had added 4x, and then I would have a division step. But in this case, I do not need to have a division step because it's just x. Alright, there are a couple problems at the bottom that have 2 sets of parentheses, so let's take a look at one of those. So let's take a look at number 9. So I'm going to distribute on both sides, and if you want to try this problem on your own, or try it in a little bit different order, feel free to pause the video, go try it, come back, and then see if we came up with the same answer. You may have done it a different way or the same way, but see if we come up with the same answer. So I'm going to distribute first on both sides. So 8 times n, and 8 times 7 made 8n plus 56. And on the other side, 16n minus 16. Then I want to get those n's on the same side. So I'll go back to my normal habit of putting them on the left. 8 take away 16 is negative 8n. And if you chose to put yours on the right, our final answer should still be the same. Be sure when you bring down this 16 that you bring its negative sign down with it. Now we have a two-step equation. I'm going to subtract 56 because I want that n by itself. And it said plus 56, so I want to do the opposite so that they would zero pair out. And then negative 8n is equal to negative 16, negative 56, add up to negative 72. Now we'll divide both sides by negative 8, so we're undoing the multiplication by dividing. Negative 8 divided by negative 8 is 1, so I don't need to write 1 in, I can simply write n. And then negative 72 divided by negative 8 would be positive 9. Okay, so keep in mind we are changing the sign on that 16n because it needs to cross the equal line to get together with the other n. If they were already on the same side, we would just combine the like terms using the sign that they already had. Alright, I hope that that again was helpful, and that I'll see you in class soon.